Today I start one important topic related to non-linear space. We also discuss now closed spaces. Okay, so we talk about closed spaces now. Here we write one theorem related to these closed spaces. Yeah, let X be a non-empty set. X be a non-empty set. Okay, then the space ABXK ABXK, the collection of all k-valued bounded function, the collection of all k-valued bounded function. Okay, the collection of all k-valued bounded function with norm x infinity equal to supremum of t belongs to x, here mod of xt is be a Banach space. Okay, be a Banach space. So we prove it. We know that this one fbxk, the collection of all k-valued bounded functions with norm x infinity, supremum of t belongs to here t belongs to x, xt. Okay, be a Banach space. So this one fbxk norm infinity be a norm space or take now. Okay, this one obviously if we want to prove, then this one we prove it, but this one we do it in previous class, so today we just write this one. Okay, so what we have to prove now? So we have to show that we have to show that okay, this one be complete fbxk norm infinity be complete. Okay, then for this let xn be a Cauchy sequence in abxk. Okay, and let epsilon greater than 0 be given. Let epsilon greater than 0 be given. Since xn be Cauchy, then we obviously xn Cauchy means satisfy some criteria of Cauchy. Okay, then we write here there exists, we write this one, there exists n0 belongs to natural number. Okay, such that this one so easily xm, obviously norm xn infinity less than epsilon for all mn greater than equal to n0. Okay, and obviously we write it here, this one, this norm xn difference xm infinity equal to what? Equal to, by definition, this one supremum of t belongs to x. Okay, supremum of t belongs to x, here mod of x mt difference x nt. Okay, this one less than epsilon. This one less than epsilon for all m n greater than equal to n0. And in we erase that portion and going to further discussion of that. This implies that here xmt difference xnt less than epsilon for all mn greater than equal to n0. Okay, and obviously t belongs to this x. Okay, then what happened? We write it again for each t belongs to x. Okay, here x and t because c x and t n equal to 1 to infinity because c. Okay, because c sequence in k, because c is sequence in k, then obviously k is complete. So we write it now. Since k is complete, since k be complete, so x n t n equal to 1 to infinity be convergent, and convergent means here we write limit n tending to infinity x n t equal to xt. Okay, here this xt belongs to k. So what we get one function x from x to k. Okay, be a function, then this function satisfies what? Then obviously we talk about this one now. We talk about later this one, or just write this one now, and later we write it. Note that xn because c. Okay, xn because c, and hence it is bounded, and hence it is bounded over. Okay, hence it is bounded. There exists m greater than 0 such that there exists m greater than 0 such that xn less than m for all n belongs to this natural number. This obviously infinity. Okay, Cauchy, and hence it is bounded. So this implies that supremum of t belongs to x mod of x and t less than m. Okay, this implies what? This implies that x and t less than m for t belongs to x and n belongs to natural number. So what we get? We erase our portion and going to further discussion of that. What we write here? We write here taking limit as n tending to infinity, limit as n tending to infinity, we get mod of xt less than m for all t belongs to x. This implies that x belongs to ab xk. Okay, then then what happened? Then this implies that here a b x k be complete. Okay, since so a b x k norm infinity be Banach spaces. Okay, we discussed so many examples of Banach spaces. Obviously, we prove all ones. Okay, so many were discussed today and previous class. So not a problem at all. How on Banach spaces we handle this one is obviously discussed. Okay, and in Banach spaces on space complete and closed, this one are equivalent, and obviously others properties are hold. Okay, some non-Banach spaces we also discussed in previous class. So we also discuss this one. That means we also these topics here. We end these topics, I think. Okay, we just discussed definition of Banach space and another so many examples of Banach space, closedness property of some space, some non-Banach spaces, complete implies closed where some are closed, how this one is happen. So we are all discuss. So if you are getting this type of video, please please subscribe this channel, and if you like, then obviously press like option, like this video. And there want any questions arise, anything you tell about something, then please write in comment box. So today I stop here.